Perfect. Okay, thank you for joining us today. Second last session for the day. I hope everybody is having a great summit, and I hope everybody enjoyed the cool live demo that happened at the keynote. So thank you for joining us for today's talk. And this talk is primarily, we had a use case in mind where we were helping a customer to build a fraud detection system. And with the learnings we had from building that system, we thought, why not that, and that architecture we thought can be used for other use cases, and that's prompted this talk essentially. So this talk is all about using business rules and business processes and making them dynamic and adaptive, and also leveraging big data that we have and how we can leverage that data to basically dynamically generate these rules, thus making our business processes and rules adaptive. So that's the whole idea about the talk. So my name is Anurag Saran, and I work as a senior solutions architect based out of New Jersey. Sal.
Hey, good morning, everyone, or afternoon, rather. My name is Sal Elrahal, and I'm a consultant with Red Hat. I specialize in the business rules management and business process management suites.
And I'm Murph. I'm a TAM in the FSI and telco spaces for application platforms.
And we also have Yoshi from Japan. We are privileged to have him come to help us in this talk, where he's going to talk about a solution that they put in place for ZOZOTOWN, which is the biggest e-tailer in Japan. And using a similar reference architecture, they were able to push the conversion rate by 5x. So really, the solution can really help you in your problem domain. So thank you, Yoshi, for coming over. So let's get started. So for today, we'll be focusing about anti-money laundering use case. We'll talk a little bit about it, or the challenges that this use case brought to us. We all love three-tiered architecture. I've been doing it for many, many years. So we also, again, followed that same approach. So the first step was to basically, we have data spread across in different silos in the organization. So we wanted to bring that data and organize that data. So that was the first. Then the second, we wanted to analyze the data and see the kind of transaction the customer is doing, if that transaction could be fraudulent or not. So we want to analyze and understand that data, the data better. And then the third one, when the transaction went through the transaction processing system, and if the system said, oh, this transaction looks fraudulent, then a task is generated and somebody has to work on that task. So that was the post-classification task, and how do you basically build a UI for an analyst to work on those tasks. And then in the end, Yoshi is going to talk about the use case from ZOZOTOWN, how they help the customer. So before we really get into this session, I would really request you to put on your thinking caps. And while we'll talk about anti-money laundering as a use case, but same approach can be applied to when you're doing claim processing and doing insurance claim processing, building an offer system. So a whole lot of use cases, the same architecture can be applied. So let's get started. So we'll talk about what anti-money laundering is. So anti-money laundering started in 1920s, where these cash businesses, where they were, let's say, making $500 a day, but were depositing $1,000 in the bank account. And that extra amount was basically they were generating through illicit businesses. So this is the original problem domain. So to give you a simple example, let's say there is an ice cream vendor in San Francisco. He makes $500 a day and deposits it in the bank account, $500 every day. Now, how, as a financial institution, can identify that this $500 is normal, right? Is there something wrong? Maybe he's generating $100 and rest $400 are coming from illegal means. So how can a bank identify that? So one of the approaches we used is essentially, why not create a profile of such an ice cream vendor? So an ice cream vendor in a particular zip code, because we have all the transactions which are in the bank, we created a profile of that customer we created a profile and ran these transactions and compared. Oh, on an average, this customer is making, an ice cream vendor generally deposits $100, but here he is depositing $500. So there's a huge deviation. So there is something wrong. Maybe that ice cream vendor is really awesome, or maybe there is something wrong. So somebody has to really go and look at it. So maybe as part of the finding, we all end up eating ice cream there because he's the best ice cream vendor, and that's why he makes that much profit. But there could be something wrong. Not only that, we wanted to create those kind of profiles, but not only that, let's say it's been raining now for last 3 days. For all the other ice cream vendors, they were depositing $100. Now they're depositing, let's say, $50. Right? There is a change in the market operating environment. But this special ice cream vendor is still depositing $500-600. So we should be able to identify that change. Now, the business users can go dynamically, open the system and update these rules, but that would be very cumbersome. So what we did was how we can look at this transactional data and update these rules every day or on demand, thus making our system more intelligent and adaptive as things are moving. And that was the real challenge we wanted to solve. Not only that, we wanted to create these rules, but at the same time, we wanted these rules the business users can understand and are easier to manage and edit. So that was the other challenge. And then if you look at the anti-money laundering space, there are huge regulatory considerations or rules that needs to be implemented. So when a suspicious activity report has to be filed, when there are more than $10,000 of cash transfers that are happening, you have to file a cash transfer report. So there are a whole lot of regulations. Then Office of Foreign Asset will come up with a whole list of requirements saying that if particular geographic location is involved in a money transfer, you need to flag it. If a particular set of terrorist organizations, list of individuals are involved, you again need to flag that. So there are a whole list of organization rules that needs to be implemented. Now, we could write all these rules in your .NET or Java code, the choice of your language, but then again, to maintain and understand becomes a huge challenge. So we wanted a simpler solution for that. So we wanted to solve for that. So while building the solution, what were the key components that would make a really good adaptive anti-money laundering or a fraud detection system? So the first is we wanted to build an expert system, and that's what we are talking about, building a rule-based system. But at the same time, we wanted to also start using regression analysis, machine learning as things move forward. So for that, we wanted that. And I would really request you to go and search for Project Daikon. Red Hat has announced that. And as part of Project Daikon, we will start supporting Spring as part of containers. Then we wanted to also, when a task is created and an analyst has to work, so he needs a complete view of the customer. We don't want him to go and log in into multiple systems and work on a task. So for that, what we did was, there's another product from Red Hat, we use JBoss Data Virtualization. We also wanted to create a single view of a customer, single view of a transaction. We used JBoss Data Grid, which is an in-memory cache, and also we again used data virtualization. So other key components of anti-money laundering is that training and understanding the current rules and processes that are there, that is again a key component. So what we have often seen is when we build these systems, the business users will write the requirements in a Word or an Excel document and hand it over to the technical users. Now what happens, once these, over time, nobody updates those business documents, right, or the design documents. So what we found is with the BRMS and BPMS, the way these artifacts are, they can be treated as living documentation, and the business users can understand. Right? So they are both living documentation, they act as living documentation, and they also act as executable code. So what were the key products that we picked? So the first one was Business Process Management Engine. So if you look at this, is again a business user can drag and drop and create these business processes where the technical users can go and implement it. So again, they live as they form as living documentation where the business user and the technical user can both work on the same artifact. Again, the next one which we used and which we love is decision tables. Now, if you look at these decision tables, we generated these decision tables as part of a Pig query, which Sal is going to talk in detail how we did that. But if you look at these rules, are again, business users can understand them. If you want, you can manually go and update each of those rules. These rules can be hot deployed in the application when these rules are changing, you can hot deploy them. And essentially, if you look at these rules, these are nothing but XML files behind the scene. So what we are doing is, as part of Pig query batch processing, we generate these XML files, these decision tables, and update them in the system. So the other two nice components that we love are JBoss Data Grid, which is an in-memory cache. And recently, JBoss Data Grid version 7, which we released, which is in beta right now, supports Spark jobs. So if you are trying to do analytics, this is something to look at. We used for caching purposes, and we used, this also has a Lucene search index, Lucene engine, search engine built into it, and we use that. We'll talk a little bit more in detail as I move forward. And then we use JBoss Data Virtualization for our integration needs. So again, coming back to the three-tiered architecture that we came up with. So on the right-hand side, we had our data sources, which we connected to build a complete view of a customer. once we had a complete view of a customer, and the reason it's very important is that you can have a customer which is very highly leveraged on the institutional side, but he comes for, let's say, a home loan on the personal banking side. So you really need to know that, right? So that's very, very important in terms of making a right offer to the customer. You need to, again, understand the customer very well. Then we built a transaction processing engine using BRMS and BPMS, and as these transactions came through, they went and, basically they were stored in one of those data sources, but they went through this transaction processing engine, and these rules were fired. And if these rules suggested that this transaction looks to be suspicious, then a task was created in BPMS where an analyst can go and work on it. We also make use of MapReduce jobs, so we wanted to basically cleanse the data first. And these MapReduce jobs, the nice part with BRMS is that you can embed them as part of MapReduce jobs. You could also embed BRMS or rules or decision tables as part of the Spark job. You can do both. And Sal is actually going to talk a little bit in detail about that. So we embedded that, did our data quality checks on the data, and then dynamically we were updating our rules with every day. So as I explained in the beginning, let's say it's been raining and the average deposits have dropped, so you need to be able to identify and update your rules dynamically. So that's where this came in place. So building an adaptive system where you want the ability to update your rules, this is, again, I'm just going to reiterate. So we, as part of the MapReduce jobs, we were able to embed our rules. And the nice part about this is these rules or these decision tables the business user can maintain. And they get embedded as part of a MapReduce job, and you can execute them. And then once your data is accurate, you could run a Pig query, which could generate a decision table which can be hot deployed in your application. So as things could move forward, if you want to use linear regressions, you want to use graph database where you want to do social network analysis, right? So if you look at, there's been some research that you can reach to any person in the world by a hop of 5. You do 5 hop in your network, and you will be able to contact anyone. So the whole idea in fraud or in time making an offer is essentially, if you are a bad guy, at least in the first hop, he knows all the bad guys. So if you're trying to transform and you're trying to deal with a fraudster and he's connected directly to the main person, you need to be careful about it. So the other part was we wanted to build a very nice UI for our business users or analysts to work on. And one of the learnings, if you look at the Panama Papers that came out recently, and it was rated as the investigation of the year, but what they had a very simple UI based on a graph database where you could go and enter a person's name, and what it did was it pulled up all the information that we had and also created a graph to the businesses where his investments were, where his businesses were, and which all his connections were. So using a very simple single-page UI, they were able to crack this case. So when you're building a UI, if you look at what are the key components of a UI that you need to build for a business analyst. So once an analyst logs into a system, he needs an ability to see all the tasks that he has got assigned. Once he clicks on a task, he should be able to see all the steps he needs to complete that task. And then he needs the visibility into the business process, what the steps are in the business process, right? So he can see what was the flow that was taken and why that task or why that transaction was marked as fraudulent. So he needs that information. And he also needs to know which rules got executed, because one of the biggest challenges I have seen is because you have thousands of rules and some action has happened. Now you really want to know why that thing was that happened, why that end state was reached. So for that, you really need to identify which rules were executed. With BRMS, there's something called as an agenda logger, and that's what we used. So we could track exactly which rules were getting executed at each step of your business process, and that really helped the business user to work on these tasks. Now, right on the screen, if you can basically give any analytics that the business user would need to work on this task. If you want, you can basically bring that. So this is just a skeleton talking about when you're building a UI for a business user, things to look into. So moving on, now let's look at how we went and built the single view of a customer, and that's what we'll focus on. And again, good data is really important, and bad data is bad for compliance and bad for when you're trying to make a real-time offer to your customer. So data is key. So for that, what we did was, if you look at in this, we again made use of decision tables. So if you look at this decision table here, the field is called record ID, right? And we are saying its type of string, length is 20, and it has a pattern that it starts with REC, right? So these kind of data quality rules we were able to write in decision tables, and the business users were able to write these rules. And then these rules were executed as part of the MapReduce job. So what we did was this, as part of the MapReduce job, what we did was each record, so if you look at this was the first record, and each field and record was basically split out into different objects, and that this decision table then got executed. And what this decision table did was, let's say for first record, the value is REC001. What we did was it has to have a certain pattern, it has to have a minimum length of this, maximum length of this. So all these conditions were actually part of this decision table, and this is that decision table, right? So these objects were updated, and then we had rules which ensured that all these conditions were fulfilled. So as part of MapReduce jobs, these rules were written as part of the decision table. So the business user could basically write all these rules. And the reason we wanted the business users was, what was happening is these rules need to be updated very frequently. So we didn't want a very cumbersome process to be in place to keep changing these rules. So once we had quality data, the next phase was basically creating a single view of a customer and a single view of a transaction. So for that, we used another product, which is JBoss Data Virtualization. What it does, it lets you connect to a host source of data sources. And we have so much information about a customer in silos, and we wanted to bring all that data in and really understand our customer. And that's where JBoss Data Virtualization came in and helped us out. So it has a connect component which lets you connect to these different data sources, a compose where you can, let's say if you're creating a single view of a customer and you want to pull, let's say 3 fields from Hadoop, 5 fields from SaaS application, so you can do that. So you can merge and create a single view of a customer. And the nice part about JBoss Data Virtualization, it gives you read and write both kind of APIs. So you can read data and also write back to multiple data sources. So we exposed that out. And the other nice part about what we did was we cached all our data in JBoss Data Grid to when a new customer was created, and we also wanted to basically do pattern matching. So in this case, if you look at, we had a new customer come in as Alex Cardona, and this was his address and zip code. We wanted to see if that customer existed, because we have seen in fraud industry what happens is people will change a little bit of the name or a little bit of their address so that they become a new customer in the system. So sometimes you're trying to offer, let's say, a 5% discount on your website, and people will change a little bit of their email address with your credit card and things and all the other information as same, and then they get enrolled as a new customer in your system. So you don't want that to happen. So essentially we use Lucene engine to basically pattern match it, and then you could have a weightage or a similarity score that could be derived. So saying that you could have a rule saying that if the similarity score is between 0.9 to 1, that I'm very confident it's the same customer, go merge those records. If the similarity score is between, let's say, 0.7 to 0.9, then I want somebody, an analyst, go and look at it. Maybe it's the same customer, it could be a different customer. So at that point of time, you could start a BPM process where an analyst could go and work on it. So once we did that, now we wanted to analyze our data. And I'm going to hand it over to Sal to basically go and talk to us.
Thanks, Anurag. So Anurag now has painted a picture for us, right? We have this 3-tiered architecture, and we have access now to a federated view of our customer, right? So background data, and we know that all of the transactions that are coming in are being sanitized. We're applying some rules. So let's look at how we analyze that data now. Now remember, like Anurag said, we want to put your thinking caps on here. We're going to talk about MapReduce, writing rules in the MapReduce, generating rules from big data operation, and transaction engine usage. But what's important is that although we highlight the use case through anti-money laundering and through fraud, these principles can be applied across enterprises and different verticals. So keep in mind on how you might be using this. So we'll talk about, we'll talk about handwritten rules in MapReduce. Now MapReduce is a distributed algorithm, which means that the platform that implements it for us, whether that be Hadoop or parts of Spark, is going to be working with data that's distributed across a cluster. Now, part of the benefit here is that when we write a MapReduce job, that computation gets pushed to the data. That allows us to scale horizontally, right? But we can't just take any algorithm and chop it up, let it work with data in individual pieces, and somehow collect and organize and give us correct output. And so we take our algorithms and we fit them into these two phases, mapping and reducing. This allows us to use the framework for any kind of computation. Again, we'll go through building a profile for a customer, maybe a customer who's an ice cream parlor owner in San Francisco, and building what their transactions will look like. But you can apply almost any types of computations, just break them into mapping and reducing. So to cover, just to level set, mapping, we're going to take our input data and transform it into intermediate key value pairs. The idea here is that we'll be able to group intermediate values by some identifiers. Then the reduction phase will kick in, and we'll be able to take that grouped set of values and distill it, determine what are the characteristics here we're really looking for. So let's look at that in the example again of anti-money laundering. Our input data, our input data is going to be the transactions. So we have credit card number, maybe amount. We might have bank account types. There's some withdrawals, some deposits, all of this information. And we're going to sit down with our experts, our fraud experts, and try to build a profile. And the profiles we'll end up building are going to be for geographic location and profession. So maybe state in the United States or zip code. So we'll try to build what does the profile look like for a customer that is a gas station owner in North Carolina, right? The reduction phase is going to take all of the transactions we have in our big data store for gas station owners in North Carolina, and it's going to determine maybe the average of the withdrawals or some standard deviation of the deposits. Again, we're trying to build this profile so then we can in real time take our transactions and classify those transactions. So now we got some Java code. This is, in essence, if you have your developers stand up some Hadoop cluster and write the code, what it would look like to perform what I just talked about. So we're going to paint a little picture here. We've got Bill, he's your developer. He's going to sit down, he's in charge of implementing this new code, this feature set. And he's going to work with June. June, she's going to be our anti-money laundering expert or a fraud specialist. So they're going to sit down and June's going to say, you know, I've worked with some of the literature and we found that there are patterns with the transactions for our customers that are unique to location and occupation, like we talked about. So we want to build a profile that's dependent on state and occupation. Bill's going to start typing away. Okay, that's mapping. I know I'll take a transaction and I'll map it to this composite key. Then June's going to say, in these profiles, we're looking for the average of the withdrawal and the deposit, as well as the standard deviations for the two, just to give us a baseline at which we can compare incoming transactions. Bill might say, you know what, standard deviation, it's been a long time since I've taken statistics. Can you help me out with that? Yeah, sure. Our specialist sits down and helps them out. So now there might be some people in the audience here who have gone to a BRMS or a BPMS talk today or over the past couple of days. And if you're out there, hopefully you got bells going off in your head, right? Because the scenario that I just outlined, where we have someone who's an expert in our domain, whether it be anti-money laundering or whatever business you might be a part of, when we have those experts explaining the logic, right, explaining their expertise to developers to then encode it, that is the primary situation that we will get benefit out of introducing a business rules or business process management platform, really. Because we want to enable June. We want to enable our fraud experts, our customer service experts, to write and maintain this logic. And so what we'll do is have our developers utilize some glue code, right? And so we've written as a part of this architecture some code that will, for BRMS interaction, it'll be wrapping to that mapper interface in Hadoop, right? It'll take the inputs, it'll create them as facts, it'll insert them into the key session and fire the rules. Bill still has a role to play in this. Our technical developers are still providing the glue. What we're doing is saying, hey, that piece of logic in the MapReduce that's specific to our business, that our business analysts know about, let's put that into their hands, right? So why is this beneficial? Because June goes to a conference a week later and finds out that, hey, something else we should be taking into account is how politically exposed our customers are, right? It matters if you're a gas station owner in North Carolina and you're the mayor, or you're an ice cream parlor owner in San Francisco and you're not, right? That can affect the profile that we talk about these customers. When we represent the business logic and business rules, June can come in and update that rule, right? Likewise for the reduction phase. Maybe it's really important to talk about the frequency between withdrawals for a certain account. Again, the expert in that knowledge, June, our business domain expert, we want to put this logic back into their hands. Another benefit of separating that business logic and letting Bill take care of those technical components is that now the way we build a profile is no longer married to Hadoop, but rather it's expressed in these business rules. And so when the underlying platform changes, because Spark has almost a natural predecessor, or not predecessor, a natural evolution to Hadoop, right? It's going to be faster, it's going to use RDD. We can even now execute Spark on top of JBoss Data Grid as of version 7.0, right? We can move the underlying framework to newer technologies, get better performance while keeping the business logic the same. Because at the end of the day, when we ask the question, is a transaction fraudulent? It doesn't matter if we're using Hadoop to figure it out or Spark. And so the logic that represents is a transaction fraudulent should not be coupled to Hadoop or Spark. We need to separate that out. That's really the benefit that we'll see in the first part, using rules in MapReduce. Now, however we end up using our big data, whether it's by driving the MapReduce functions by rules or some other mechanisms, we want to make some insurances about the outputs, right? So when we talk about the outputs, we've been talking within the context of this customer profile. And so if we're using different data sets, again, this goes back to what Anurag said about building a single view of a customer, right? We want to be able to take our real-time data, like the transaction data, and color that with the single view of a customer that we've determined. Again, using things like data grid for the Lucene, the querying and compatibility there. And so in this example, when we're joining transaction information with account information, right here in our Pig script, and we're joining across those and pulling, this is a different way of processing our data, right? This is fundamentally different than using the business rules as part of the MapReduce logic. Here, we're using Pig. The idea is no matter which way we create these decisions, it could be Pig profiles, it could be business rules, it could be linear regression, social graph, machine learning. Whichever way we end up bringing that data out and distilling the information, representing those information, or that information, as a set of rules that can interact with business processes is going to give us a lot of flexibility. And the reason why is this last portion, the transaction engine usage, right? So we'll move from analyzing historical data to creating actionable and adaptive assets that our current classification engine can use. That way, every transaction that comes through, we have a set of assets that we can apply. So let's look at what I mean by actionable. You'll see here we're using a business process to kick off two different sets of rules. Rules that might be handwritten or rules that might be generated from Hadoop, Hive, Pig, a number of sources, right? Whatever you might choose. The point is we can use Business Process Management Suite to interface with these rules directly. And Murph is going to go over a lot more features and flexibility we get from using the BPMS layer there, so we're just going to leave it at that. Actionable, again, we want to make sure that the big data we have, it's great to use rules and to reason over it and to perform calculations, but at the end of the day, if the output of that process is not something that through action can provide business value, then why are we doing it? And so making sure that we're generating these tables that are actionable, that's huge. The other part that I hinted at was adaptive. And this is adaptive in two senses. The first sense is historical. Anurag hinted at that. Maybe we've got weather, horrible weather in San Francisco, right? And that starts to affect the profiles of our ice cream owners, our ice cream parlor owners, right? We need our rules to be adaptive and to work and update themselves. And so by making sure that every transaction that comes in being stored in our big data solution gets run and transformed into these profiles, we generate the profiles at a certain frequency and we're always using the latest data. This is the adaptive nature. And so sure, the first couple of transactions that come in from the San Francisco ice cream owners, they're going to be a little bit off, right? They're not going to conform to the profiles that we've expected in that region. But as we build up our backlog of known non-fraudulent transactions, that's going to affect it, and our classification engine is going to automatically get updated. And that's the adaptive nature. You'll see here with this decision table, we're actually setting a score for each transaction. The second and last portion about adaptive nature is that score that we're setting. This is our transaction engine rating a certain transaction and saying, you know what, relatively, this is probably fraudulent, or relatively, this is probably okay. What we want to still do is enable our domain experts to influence this process. We'll have June sit down and set threshold values and say, you know what, if a score is above 80 or a score is below 70, what we're going to do is flag it as high and make sure to block the transaction and create an investigation. And so in this way, we're enabling the business owners, these experts that we have in our system, to not only create the rules and create the profiles, but be involved on the other side of it, on the analysis of that data. And so again, just to cover, these 3 points that we're talking about, the analysis of this data, we've painted the picture within the anti-money laundering sphere, but thinking caps. Right? This can be applied across a wide variety of industries and verticals. We've got the time and we're highlighting its usefulness through anti-money laundering, but think about how you could use handwritten rules, how we could create a MapReduce job from the domain knowledge that we have, how we could generate the rules and make them actionable and adaptive. And so now I'm going to hand it off to Murph. He's going to cover these post-classification tasks.
Thanks, Sal. I feel like air traffic controller here. So you'll notice that we highlighted the transaction processing engine both on the analysis side and on the post-classification side, and that's critical. We were using the rules execution environment to generate our classification profile, but then we're also going to use that same engine, that same technology, in order to drive our business analyst user interface and take those adaptive generated profiles, turn them into actionable results, and actually improve our business thanks to that. If you've gone to some of the other BRMS sessions, you may have seen this type of design pattern diagram. This is how we filled it out for our application. You can see we're using both the document-based generation, those are your Hadoop or Spark-based dynamic profiles, as well as guided editing. Those are your expert-generated rules and processes. We're going to look at a couple of those. Then moving along through the architecture, you have versioning, deployment, and storage elements. And we're going to look at what that logical and physical architecture looks like, taking the data that you have, moving it into your runtime environment, and what some of the moving pieces are there. So we saw our document-based generation. If we look at our guided editing environment, so this is just a snapshot of the workbench from BPM Suite. You'll hear us use BRMS and BPMS often interchangeably. Often it's just BXMS. Ultimately, it's the same technology under the covers. And what you get is this environment known as Business Central, where you can author either your process assets, your rules assets, in a number of different formats. Ultimately here, some of the color coding, the light blue boxes, those are our rule environments. The first one, the first set of rule execution, we're actually running that profile against the transactions that are coming in. We may or may not be flagging them as fraudulent. The red node there is a user task that we may assign the task to be further processed by a particular analyst. Then once that processing is complete, the next node is a custom hand-coded rule node where we're determining what the remediation task should be based upon the results of the work that that user took during that task node. The output of that is a dynamic token. What should that remediation process be? So I zoomed in here a little bit so you can see it. You're actually able to use placeholders and variables in order to drive the evolution of this process. So you're not hard coding the entire workflow. This enables some degree of future proofing in your process design let's say the remediation steps change, we have a new remediation pathway, the high-level process doesn't need to change. We're able to set additional variables within our decision tables to then drive what the new remediation pathway is going to be. Talking about versioning, building, storing, and deploying, this is a snapshot of a typical environment. One of the key things to take away from this, we've talked about the horizontal scaling you get with Spark or Hadoop as far as the data ingestion and the data processing phase. But then in the runtime phase, you have that same horizontal scalability available to you using a farm of key servers. So these are your remote execution environments, easily managed and maintained from a central location. Those are your workbenches, your business central, which is clusterable. You can have a multi-master sort of setup there. And then those remote environments, you're feeding your transactions into that, as well as your rules calls, your rules executions. Similarly, you could embed those same capabilities. So when you're in your workbench, you've authored your process, you've authored your rules, you hit build and deploy on the UI there, and the output is just a Maven jar. We call it a K jar, but it's ultimately just a Maven artifact, easily embedded within your application, embedded within your MapReduce job, embedded within any sort of utility that you might want to use. Also deployable to your remote farm for your high volume transaction processing. What is that process that you're feeding into? How are you going to get your transactions into it? So this is our overall transaction flow, and that start node is where we're going to want to insert our transactions to kick this whole thing off. So this is a snapshot of what that code might look like. In your Java application, your back-end systems, you want to tie into that farm, so you establish a remote session with one of the builders. This is using the REST interface. There's also a JMS interface, a SOAP interface. Whatever you like, the API is ultimately the same. Even if you're using embedded code, the API is the same, which is a great advantage. And then ultimately, you just call start process, passing in that transaction data as the parameters to the process, kicking off the whole chain. Once that's in the pipeline, how do you then enable your users to interact with this system? Now, you can use the built-in task management, process management capabilities in the workbench, but you likely already have a UI that is aimed at your business users. And you don't want to have to use iframes. You don't want to have to link out to an external system in order to enable them to interact with these things. So you want to embed that knowledge directly within your UI. So you may have an existing set of graphs and interactions that you're already exposing to them, but now you want to add their task information at the top. So up here, we've got the data is actually being sourced directly from the execution environment. You're pulling the number of active tasks assigned to that user. You're pulling historical tasks. You're evaluating priorities that are set on those tasks in order to give them a good dashboard and a view into what they need to care about, what they need to interact with. This is a snapshot of what the JavaScript code, the client-side JavaScript code might look like. So this is in Angular. You can use React. You can use just raw HTTP and HTML and CSS or jQuery, whatever you like, whatever your framework of choice is on the client side, because everything's exposed through REST endpoints and JSON data streams. So whatever you like to use is available to you. This example is showing retrieving from the query API. So the key servers have a built-in query API that allows you to interact with that underlying data in a powerful way. You can develop custom queries. You can interact with some of the stock queries. Here we're just pulling back whatever tasks are assigned as a potential owner to me, the user. We're also using, you might notice some of these authentication headers, using some of the capabilities here that are enabled by Red Hat SSO, which is built into the latest release of the BRMS BPM suite packaging. So you're able to have single sign-on between the engine and your API. So you're not managing service tokens and you're not managing any sort of translation between who's doing what. You get direct access to who you care about. Pull the data back, we're parsing out the task summary, and then we're exposing that data in the UI. Then once it's time to actually interact with the task, here you go. You're able to add claim and release view buttons, interact with the tasks, whatever state they might be in. Here we've got just a couple of examples around. You may have a task to review the suspicious activity report for these particular accounts. Once the user has decided that it's time to do their thing, they're able to interface with it and drive that engine through your client-side interface. To summarize what we've already covered here, first, we brought in our data, we cleaned it up, we did some quality checks on it, and then we consolidated it into something that we could actually analyze. We processed that data through our MapReduce or our Spark or whatever our big data analysis tool might be, generating some dynamic rules and a customer profile that we could then feed into our business processes. And while doing that, we enabled our business analysts to feed their knowledge, their expertise into the system without having to understand the underlying code, and while eliminating that extra layer of writing documentation, understanding documentation, and trying to implement it. There's a lot of opportunity for missed connections there. By giving your experts direct access to the environment, you're closing that loop a lot tighter with fewer opportunities for error. So what's the flow look like? We've got our architecture. Just to give you a picture, a complete picture of the data flowing through the system. In our happy path, transactions feed into the application. They get loaded into our big data store as well as fed into the transactional system. We determine that this particular transaction goes through our customer profile check, and we determine that, no, it's okay. Right? No remediation required. It passed. The transaction score is sufficient. We think it's cool. It's good. Now, if a transaction comes in that we think is suspicious, when it hits those rules, an alert goes up, and a task is assigned to a particular business user, an analyst, fraud analyst, for additional work. Right? We want to enable them to analyze that transaction, so we're going to go ahead and expose our historical data, which has been loaded into our data grid and made easily accessible to the UI. We're also going to expose our execution history. Anurag alluded to this earlier. We're actually keeping an agenda logger and a log of all the rules that have fired against this particular transaction, so we know exactly what's wrong with it. And we're able to expose that through the UI. Give all of this insight to our analyst and enable them to make a highly informed decision. They then determine that it's a fraudulent transaction. They flag that within the system, and we kick off additional processing, the fraudulent transaction process, and whatever remediation has been flagged for use. Once that's done, though, great, right? So we have successfully created a system that intelligently routes transactions through the correct pathway. But we've learned something, and we want our system to learn that as well. The analyst may have discovered some additional information. They want to feed their analysis back into the system. So we're actually going to have that analyst update the rules in accordance with what they now understand. Perhaps they want to permanently flag this account as a fraud danger, so that any new transactions short-circuit the rest of the analysis and say, no, this one's done, dump it right in the fraud bucket right away. So we're able to take that insight, feed it back into our engine, rerun our generation job in order to generate a new customer profile. That is automatically loaded back into our key server farm, so all new transactions will receive this updated insight and this updated knowledge. So that summarizes our architecture. I'd like now to hand it over to Yoshi, and he'll talk about their solution.
Thank you. Let's start. The mere of success cannot be true success. Sorry. The mere success of a project cannot be considered true success. What success truly means is something that would bring huge business benefit, not only in the short term, but in the long term. Hello, everyone. I'm Yoshiki Nas, as the manager of a Big Data Promotion Office at NTTData Corporation. NTTData is a global IT innovator. I'm glad to have this opportunity to speak about my experience on my project, and I'm very exciting to share with all of you the current spectacular project I'm working on in Japan. Today, I'm talking about the next generation digital marketing platform, and I will explain how this new system helped multiply conversion rate by 5. The use case is internet fashion retail company in Japan, and the company is called Start Today. And the name of its major service is fashion e-commerce site ZOZOTOWN. This presentation consists of the 3 following topics. First part is about challenge. I'd like to share the concept and the difficulties we encountered during the project. Second part is about solution, in which I will share some approaches and key factors which were used in achieving our goals. And lastly, I'd like to discuss the lessons learned and the benefit and business profit of this business. Before sharing each topic, I'd like to share our client, the overview of our client. Start Today is Japan's largest internet retail company, so it handles 3,500 famous fashion brands, and the total annual buyers reaches over 4 million. And this company is very absolutely aggressive. So all these encompass their company's principle, which is make the world a better place, bringing the smile to the world. And there are major services, especially fashion e-commerce site ZOZOTOWN, that has over 800 stores and 300,000 items. In addition to this, there are major services like SNS app called Where and flea market apps, ZOZO Furima. This company creates new service for their customer very daringly. Now, let's study the concept and the difficulties of our project. CFM stands for Customer Friendship Management. This is an evolutionary way from CRM, Customer Friendship Management, to make better relationship with our consumer by establishing friendship with them. Before starting our project, there is a stage called CFM 1.0. At this stage, they focused on right content and right personalized email. And then at this stage, they were already able to gain the 10 times sales volume compared to the first CRM stage. However, they sought to be transferred to the real-time stage called CFM 2.0 in order to provide faster and to gain more extreme marketing processes. So we needed to focus on these keywords, agility and optimization, such as content, channel, frequency, and timing, to implement the function real-time customized optimization into our system. Surely, this is a great challenge because at the to be CFM 2.0 stage, in scenario-based approach, our customer required real-time transfer. Definitely, this is a current trend, so our client wanted to keep up with this trend and to prefer to be familiar with the advanced approaches. This is system architecture which we aim to finish eventually as a digital next generation digital marketing platform. And there are consumer and as-is source system, such as e-commerce site and CRM database. This architecture is able to 80,000 web access logs per second and another source DB data on in-memory cache space at real time. And this architecture is able to execute customized optimization processes by business rule within 10 seconds. And then we will deliver to reach target consumer speed and extremely output similar to LINE with multi-channel similar to LINE. LINE is an SN service in Japan. Therefore, there are three solution components: real-time data, flex business rule, and big data. The fusion of these components is the essence of our system architecture. After this, I'd like to share some approaches. We followed three important steps in realizing the concept. The first step is making business concept. In this case, it's transforming to be in real-time stage. So we needed to emphasize the concept based on personalized user needs and wants clearly with all project members. Second step is the concept divided into solution components. As you know, for our project, the core key technology are BRMS, Business Rule Engine, and Data Grid product. Lastly, the third and important approach is trying to make a quick hit by agile method for field testing. Indeed, I did testing on the third month, which is also 3 months before the launch. It gave us more confidence of a business profit with real-time data, real-time marketing. Now, this is the most exciting part. I will show you the result of our project. The following figure is a real business benefit, like sales volume. This is an example of one real-time digital marketing campaign, its positive outcome. By adding real-time capability into as-is stage, we were able to stretch open rate by 2 times, conversion rate by 5 times. Open rate is the number of confirmed message and coupons. Conversion rate is the number of purchased items. As a result, we were able to gain about 10 times by 5 gives 50 times the sales volume compared to the first CRM stage. This is a great impact into our client marketing campaign performance. Lastly, I'd like to present the conclusion of our project. Now we were at the CRM 2.0 stage. After realizing the concept, solutions, and approaches, which were mentioned in the previous slide, we were able to deliver a clear picture of business platform. Not only as a computer system, but also real-time digital marketing strategy. The business platform will continuously improve and satisfy our client business process in terms of marketing to be able to produce more sales after this. As we end the presentation, I'd like to thank all stakeholders and our project member. Your enormous effort, support, and amazing performance was of great help in achieving our goal. And those who present here, thank you for taking time in listening and appreciating our project. Thank you.